Well, thank you for that very nice introduction. And I'm glad to be here today. My name's Gary Klein, no relation to Nancy that I know of, right? So on June 24th, 2021, the eastern portion of the Champlain Towers South condominiums collapsed. 98 people died. In terms of loss of life, it is second only to the Hyatt in 1981, if you exclude terrorist events. So a very significant structural collapse, and that's what I'm going to talk about here today. Okay. All right. I'll first outline our investigation objectives and approach, talk about findings and observations in the various activities, document review, site observation, laboratory testing, structural analysis, and then get into the theory of the collapse, and I'll try to then wrap it up all in about 30 minutes. So in terms of investigation approach and objectives, fairly simple, right? We did these steps, reviewed documents, investigated conditions at the site, conducted laboratory studies and structural analysis, all aimed at determining the root cause. Matt Fadden and I were involved as expert in the civil litigation, and that's how we got involved in this project on behalf of the ownership of the condominium association. Let's get right into it. Here's what we knew going in on June 24th, 2021. The building had collapsed at 1:30 a.m. Initially, 100 plus people were feared missing or dead. Ultimately, 98 people perished in the event. The cause was unclear. There was a lot of speculation, as you might imagine, in social media and other sources, some of which was actually very helpful. And here you see the site in Surfside, Florida, which is north of Miami Beach, a very high-end area and becoming increasingly so, especially the oceanfront properties. This is a photo after the collapse. To the right is the eastern portion of the tower, which had pancaked down, and where, of course, most of the people perished. And to the left, you'll see the swimming pool and the pool deck surrounding the swimming pool. And it's a little hard to see at this scale. You'll see in the next slide a closer view of that pool deck, which was supported above a parking garage, and that had collapsed onto the level below. And those circled areas are columns that are poking up through the pool deck, indicating a punching type failure. All right. The 12-story building is L-shaped in plan, 136 units built in 1981. It's a flat plate construction. And there you can see what flat plate looks like if you're not familiar with it, just columns and slabs. There's a parking garage on the lobby level. And there you can see the parking structure and a pool deck terrace on the south side of the building. There's the pool deck and the pool and the pool deck that surrounds it. In plan view, you can see the pool deck in the southeast portion of the property and the tower that surrounds it, and the entrance area to the west. And we're going to talk about that entrance area in a minute as well, but I wanted you to be familiar with that plan. And the next photograph or image you'll see is of the level immediate below this main level or this entrance level. And that was devoted entirely to parking, like a lot of structures of this type. They have parking in the lower level, and that's why the pool deck was elevated. That's the point. Let's go through some of the history found in the documents. And in 1996, there was a retrofit work where there was new waterproofing, including waterproofing of the planters, installation of additional pavers, as well as concrete structural repairs. And the All was by Western Waterproofing, was signed off by a structural engineer. And the point is they added load in terms of new pavers in 1996. And we'll get into that. The building was approaching 40 years old, and in Florida, and after 40 years, you have to recertify the buildings. And they hired a firm called Maribido to do that, and they were in the middle of an investigation. And we learned a lot from some of the investigative work that they did. I want you to focus in now. Here's another plan view, and focus it on this rectangle. I'll blow it up. And in two areas, they took concrete cores, which we found to be very useful in understanding the construction of this pool deck. Both in the parking area to the left and the pool deck area near the planters to the right. So here you see the two cores that were removed, and they look all cracked up, but that's pretty common in the coring process to get these kinds of cracks. We don't believe they were pre-existing cracks. But I also want you to notice in the parking deck, the topping slab. In fact, in the pool deck, there's also a topping slab. That was not clearly shown on the original design drawings, but it was clearly part of the original construction because the tile and mortar finish was specified. So they must have known about it, but again, it wasn't on the drawings that were issued to the building department. Okay, so thick topping slab, keep that in mind. So from those core samples, the areas in black are areas that weren't included on the original structural drawings. Okay, the 3.6-inch topping in the parking deck, and then about 2 inches of topping in the pool deck, plus pavers, and that were part of the 1996 work by Western Waterproofing. So there's some added dead load in both the parking deck and the pool deck. Is there another way to fast forward? Okay. This doesn't work. When I raise my hand, advance the slide. One of the other things that we found from the Maribido investigation is the planters weren't the same as shown on the original drawings. Those shown in dark green were original and matched what was there. In light green were added planter areas, and in kind of that pinkish color were planters that were planned but removed. The point is there's some additional load from planters as well. Now this is a section near the north, or rather the west end of the building where the entrance was, and we found this in Maribido's documents, and they had done an analysis of this area, and they focused on this area because there's going to be some change of use and some additional allowance for live loads and things in the entrance. But the point is that they did an analysis along column line T in the area outlined by orange. And in that analysis, the computer spit out the punching shear stress, and in every case it was exceeded. But apparently they did not act on that particular finding or ask the same question if punching shear was exceeded elsewhere in the structure. It has to do with the original design. I just lost all my slides. And maybe we should take questions at the end, but that's a great question. But it's because I'll get into that before we're done. There was a walkthrough video of the structure that we were able to get a hold of, and that told us a lot about the pre-existing conditions before the pool deck collapsed. So now we're in the parking garage. The pool deck above is to our right? So this is looking east towards the ocean, and the lobby is to the left, and there's a step, actually two different steps in the slab elevation, as can be seen by the conduit and pipes in the area. So keep that in mind. And notice also, there's where the steps were, but notice all the water also penetrating through the slab. In that video, we were able to piece together that photograph or mosaic photograph on the right, and at column L13.1, which is circled in the diagram on the left, there's a lot of water that was coming through at that column, and you can see the deposits at the base of the column. And that can happen when there's punching shear distress, if you will, or shear cracks in the vicinity of the column. Water can find its way through those cracks. So not exactly a smoking gun, but some indication that there may have been a pre-existing problem. But here is a smoking gun. This is the planters above column K13.1. And I want you to notice the cracking horizontally in the planters, the apparent sag, if you will, of the slab, and the faulting between the portion of the planter on the right and that portion on the left. That garbage can that you see at the far left was removed so they could take that photograph, and you can see the rust stained area from the garbage can. And there's a close up of the faulting. Now, unfortunately, that was noticed but dismissed as something to do with the planter itself, not with the underlying structure. And this slide is from April 2020. Okay, the previous slides were from June 2021, just 3 weeks before the collapse. Now here we have a year or so earlier. None of that distress exists, right? And there it is after the collapse. That's the column in question. That's a planter. You can see to the left, the planter wall, and you can even see that rust staining from the garbage can at the lower arrow, okay? So what we think happened, or what is that those spans had begun to sag as there was rotation near column 13.1. So a blow up of that sketch below, the horizontal cracking in the planter walls, as well as that faulting between the two sections of the planter, is consistent with significant structural distress that was pre-existing. Okay. Now we're going to go through a little bit of other information we found in our document review. I show this slide because the units facing the south were also overlooking the pool deck, and there's certain evidence from those units, if you will, that tells a story. Now, this is a little bit tedious, but there were several events between 11:10 and 11:15 or so that related to the pool deck collapse. The security guard felt rumbling and saw white dust in the air, very loud noise. The building began to sway, and guests in the Blue Green Resort, which is to the north, heard a loud crash and felt the rush of air rushing from the garage. All those were consistent with the pool deck collapse. Now, it's not until 7 to 12 minutes later now that you have the building collapse, and where 3 columns you'll see from these videos, and I'm going to focus on these 3 events. The guests at the Blue Green Resort. Let me start with that. So this is a video taken from the north looking into the parking garage at 1:18 a.m. We did the best we could to enhance that photograph, and you can see the debris already lying on the parking garage floor. You can see a couple of columns in the garage. One column in particular was not there, may have been knocked down. We're not just entirely sure. So that was, at this point, the building is surviving, but the pool deck had collapsed. And now we have a ring video from Unit 711, which also overlooks it. And this is kind of in between time, between the pool deck collapse and the building collapse, right? In 7 minute span or so, there's a lot of distress 7 floors above the pool deck collapse, indicating significant subsidence of those columns, but not immediate collapse. Then by 1:22 a.m., we have this video from a security camera. You can see the Champlain towers in the background on the photograph or video excerpt on the left. And when you study that video, you see that the collapse started, it's in progress at this point, at the base of those columns on the south side of the tower in the central portion, area 1, if you will. Then in the illustration on the right, area 0 is the pool deck. Area 2 subsequently collapsed and followed shortly thereafter by area 3. So let's talk now about the site observations. This is the view of the site as we encountered it. We didn't get access until October of 2021. At that point, all of the debris had been removed by the National Institute of Standards and Technology. But then we were free to do whatever site investigation, along with, in cooperation with a number of other engineering experts representing various parties in the civil litigation. One of the first things we did, though, was a survey of the base of the basement slab, the parking garage slab, essentially. And this is the survey results, and it was extremely flat. There was a lot of speculation, as can happen in karst formations in South Florida, that you have a foundation failure of some type, but that was not indicated by this survey of the basement slab. We did a lot of sampling at the site of the concrete or the reinforcing, several borings of the foundation, and I'm going to summarize what came out of all that. And we also had access to what's called the primary evidence facility. So NIST arranged for fragments to be removed and saved in a warehouse. And there you see a couple of our engineers in that warehouse, and they were able to make this drone mosaic, if you will, of what the specimens laid out in the primary evidence facility. One in particular was interesting. There wasn't as many. It was disappointing, in fact, that there weren't that many reserve pieces of the slab, but this was one of them. Its location wasn't specifically identified, but we know it's the pool deck. And what you're seeing there in the photograph on the top and on the right is a punching failure of that particular slab. And I also want you to notice in the image below, there's about 2.5 inches of cover to the reinforcing steel. That's the bottom layer of the top mat. But what that meant is the steel was 1 inch to 1.25 inches lower than it should have been at this particular location. And that's relevant because punching shear strength is related to effective depth of reinforcement. That's one of the columns that was at the primary evidence facility, and its appearance was consistent with punching failures. Then the question is, how did this punching failure lead to the building collapse? And I want you to look at the photograph in the middle lower section, which is a 3D image. It shows how the pool deck connected to the building in those 2 steps. And the green beam is referred to as beam A. And what you're seeing is some photographs of beam A, which were really too badly destroyed to learn very much. There were also portions of the column at the south edge of the building. And this photograph shows that column at the connection at beam A, and that divot, if you will, that's taken out of the, out of that column section shows that the depth of the reinforcing was more than expected. Now, remember, this is at the top of a column where they're going to have a joint, and we're going to lap a lot of number 11 bars together. And apparently the cage was moved over such that there was pretty excessive cover. And that becomes important for reasons I'll explain in just a minute. All right, so what do we find from all this? The concrete was typical to Florida. The corrosion was consistent with that at the time of concrete placement. No evidence of advanced corrosion we could find at the primary evidence facility, but there was some corrosion at the site nonetheless. But chloride levels were low, very little carbonation, and the steel and concrete strength were about as expected. So as I said, we're dealing here with punching shear failures. We believe that's what started it all, probably at the column circled in red, which is K13.1, which is where I showed you earlier, had that evidence of distress in advance of the collapse. When you do a design review in accordance with the 1977 ACI code, which was the relevant code, you find that it did not meet the design at the time by quite a margin, both with respect to bending moment and punching shear. And you see those red cells are ratios of demand to capacity, and they go as high as 1.9 or even 2 in some locations, particularly along the K line. So it was not designed correctly. And this is also evidenced in this shot where we did a finite element modeling, and you see at the first interior main longer span that the positive bending stress is much higher than it should be. So let's get right to the theory of the collapse. I want to refresh your memory. I want focusing now on the K line. We're looking north along the K line. The pink area is the garage below the pool deck. The greenish blue area is the lobby. So as those punching shear failures develop, the slab, as shown in blue, begins to drop down, right? And as it does, it goes into kind of a catenary behavior. And at the south side of the building, which is shown at the right here, right there, there's a lot going on. And you get both catenary action and bending that wants to pull out beam A from those columns. So there again is beam A and the column detail. And the blue areas represent the bending forces, right, from the beam A collapsing downward, and the orange arrows are the catenary forces if it did develop catenary action. And both of those combined to cause a very high degree of tension at the top bars in beam A as they connected into the columns at the south side of the main building. And this was assuming the reinforcing cage is per plan. So as that beam collapses, it pulls out a chunk of concrete out of that column. Now, this is speculation at this point, but it is consistent with the evidence, and we know it's also consistent with what NIST is thinking at this point. And then that column subsides, and it subsides and holds for a few minutes, as evidenced by the video before it totally collapses. Now, in a second case, if that reinforcing cage for the columns is shifted to the right, that makes it even easier for that chunk of concrete to pull out. And we may never know what the specific conditions were at the column in question. So then the theory of the collapse is the pool deck to the south of the building fails. That's supported by the residents and video documentation and the observed punching shear failures. And then because of those horizontal forces I just discussed and catenary forces, the strength of the column is diminished at that connection, leading to collapse of the south exterior columns and ultimately the eastern part of the building in several stages, as I discussed: initial subsidence, then the collapse of areas 1, 2, and 3. The western portion of the building remains intact, and it was protected, if you will, by the shear wall at the elevator core. So what mistakes contributed? First and foremost, the inadequate design of the pool deck slab, especially for punching shear, in accordance with the 1977 code. Second, to your question, there was excess weight on the pool deck, right? There's the addition of pavers, larger planters than originally shown, and a concrete overlay that was known at the time of construction. It was not sure if it was known to the engineers or not. Okay. And thirdly, shallow top reinforcing, decreasing the effective depth and enhancing the likelihood of a punching shear failure. So all those things combined, even in the absence of live load at the time of the collapse, are sufficient to explain the collapse. And then we'd be remiss if we didn't mention, it's a mistake, that the engineers responsible for the recertification failed to identify the warning signs, right, from their own analysis and some of the distress that was evident. And so there's some other contributing causes. One is long-term sustained load. Concrete fails at a lower stress if the load is sustained, and the dead load was sustained for more than 20 years, including the new pavers. Low top reinforcement ratio. What I mean here is the amount of steel clustered around that column met this was proportioned according to 77 code. The code now requires more of a concentration of reinforcement. There was water buildup in the planters, perhaps, and corrosion. We don't really know to what extent that was significant. We didn't see any strong evidence of that, however. So that's it. As to why it collapsed, I'd be happy to take any questions, time permitting. You mean for the recertification process? Yeah, so they did the analysis of that area to the west where they had some additional loads, and that was the results of those analysis. But when their own analysis shows that the punching shear stress is exceeded, they didn't take that additional step to say, well, maybe it's exceeded elsewhere in the parking deck or the pool deck, which is very unfortunate. Yes, sir.
And just a reminder, I will walk the microphone over to the next question.
Yeah, the photograph of around the planters that showed the faulting, I think it was that done during the pre-certification process?
That was a photograph taken by the recertification engineers, Maribito. We found in their files.
So what's your opinion about that? I mean, 100 engineers looked at that. How many would have you used the term dismissed it? How many would have dismissed it?
Yeah, that's a great question, because hindsight's a beautiful thing, right? And after you know this had happened and we saw that photograph, we go, oh my goodness, this was a warning sign. But and it was an engineer who took that photograph, but didn't really kind of put together what they were seeing. And you have to ask yourself that question. If you had seen that, in the absence, not knowing about the subsequent collapse, would you have for sure raised questions about it? You'd like to think so, but I don't think there's any way to be certain. There's no records of the construction. Fortunately, the plans as submitted to the building department were retained, but there's virtually no other construction records.
Was there a specific event that triggered the collapse? You'd mentioned some construction or something.
So that's a great question. And this event, more than any that I've ever investigated, or as much as maybe a few, it occurs out of the blue and without an obvious trigger. And I'll go back to the discussion about sustained load. If you sustain the same load for a long time, you can eventually get a failure without a specific trigger. And I have to think that the trigger wasn't so much additional load as it was, micro cracking and loss of strength over decades that it finally gave way.
It's been a very long time since I thought about it, but is there such a thing as concrete creep? And does that have anything to do with this?
Well, yes, it does. And it relates to this effect of sustained load. Creep, micro cracking that causes creep, right, is a time-dependent effect. And we don't specifically recognize that in designs because usually the dead load effects are masked by the live load requirements, right? The total load is a lot more, so dead load alone is not a big deal. And the codes require a higher factor on dead load if it's acting essentially alone. But when you look at what caused this collapse, sustained load and creep and micro cracking were very much part of the picture.
So following the collapse, has the state of Florida changed the way they conduct, I want to say, recertifications?
Yes, and I don't remember the details. Matt knows them better. We have an office in Florida. They made some immediate changes, and I think they're looking more carefully at their recertification process now, including a reduction from 40 years to, I think, 20 years. But remember, one of the things is that a lot of times it calls for an inspection. And some of this distress maybe could have been seen in an inspection, but often an inspection alone, especially as it relates to the possibility of punching shear, is inadequate. And that's something we have to struggle with.
We were told that the owners were presented a bill that they needed to do to get that recertification. Do you know what the structural improvements anticipated as part of that rumored improvements needed, if that would have addressed it?
Well, the short answer to that, Nancy, is no. They would have had some strengthening in the west area where I showed you where they did that analysis. They were changing the loads, but there was no general strengthening of the pool deck per se as planned as part of the recertification process.
All right, we've got one last question.
I had a situation on a project in Florida where I had a layer of poor substrate as we went down through with pilings. It eventually punched through it. And I had wondered if there was anything with the pilings or anything done here that eventually had possibly punched through and got into some issues that affected the bearing strength, which could have caused a failure.
Well, that's a good question. And early on, there was certainly a lot of speculation because that kind of thing happens in South Florida. They have these karst formations, and over time, voids can develop below grade, and there have been examples of sinkholes and foundation failures for that reason. But remember that the slab that supported the entire building remained dead level, and there were more than a dozen soil borings, maybe as much as 24 soil borings, I think, taken and looking for that kind of thing. No evidence of that. Ultimately, what they use is something called Frankie piles. I don't know if you're familiar with that, but they essentially drive aggregate down and it forms a pile. But they were only about 15 feet deep or so. But they're more of a soil improvement than a real pile. And one of those piles was removed. But the bottom line, as far as we can tell, that kind of thing did not play a role in the collapse, although there was that speculation.
All right, the last question.
Thank you, Gary. Great presentation. It's really not a question so much as in, so what's the current status with the civil court cases, et cetera? What's the current status of what's going on with this project?
I'm sorry, repeat that?
What is the current status with the civil court cases? What's
the current
happening?
status of it?
Thank you.
So good question. The court case has been settled. They had a terrific judge. And so we did our investigation to try to inform our client, which was the condominium association and their attorneys and their receiver, as to what happened. In the meantime, these parties are negotiating settlement under the guidance of this judge. And they agreed on settlement not about a year after the collapse. And they had contributions from various parties, including the building to the south, where it was alleged vibrations from its construction played a role. The security firm kicked in a lot of money because, and I didn't mention this, but they had a fire alarm system and they tried to trigger it when the pool deck collapsed to get people to evacuate, and it didn't work. And as I understand it, They then were going to use a PA system, but the security personnel in charge didn't know how to operate the PA system. So a lot of money came from that source. The original design and construction firms were gone. So it was unusual in that sense, but I have to credit the judge and the entire legal team for coming together to achieve a settlement. So there will be a lot of fair compensation for the families of the deceased as well as other owners. Almost $1 billion.
In the letter, was there any evidence that water and or has there been significant rainfall that could have been raised in water?
Yeah. So the question was there accumulation of water in the planters? That had been an ongoing problem. The planters didn't drain properly. They weren't very well waterproofed and so on. And we don't know how much water may have accumulated. That would have made some difference, not a major difference, but those planters in question, right, weren't preserved, and there was no documentation of that. The only thing we found was kind of a history of issues with planter waterproofing and planter drainage.
Thank everybody. Thank you, mostly.
Thank you. Thank you.